jump in. All right, so solving polynomials by factoring has 3 major steps. Number 1 is to factor as normal with any of the methods that we were learning before, right? So we can use any of those methods. Remember that some of them are better for other things, right? So difference of squares and cubes, this is going to be if there's 2 terms, right? Quadratic form, these are the ones with 3 terms. And then factoring by grouping is like 4, 6, or 8 terms. Right, so if we have 5 terms, we're kind of messed up. There's not really anything that we can do. I don't think. Yeah, not too much that we can do if we have 5 terms. But if we have 2, 3, 4, 6, or 8, we're in a really good space for that. I guess with 5 terms, you could potentially look for GCF. You can do GCF with any number of terms if they have something in common. All right, so we're going to jump into this first one. We're going to factor as normal. We're going to set all the factors equal to 0, and then we're going to solve the factors. So since I see that this has x to the 4th here, right, I'm going to use the quadratic form with x to the 4th power. So for this one, I'm going to look for a GCF. I don't see a GCF, so I know that I have to do 2 times 2. That's my number. I need to multiply to get 4 and add to get -5. Anybody got me on 2 numbers that multiply to get 4 and add to get -5? You can come off mute, you can type them. -4 and -1, yeah. -4 and -1. Right, so -4 times -1 would give me +4. -4 plus -1 gives me -5. Because I multiplied in this 2, I now need to divide that 2 back out. Right? I now need to divide that 2 back out. So I'm going to go ahead and simplify here. -4 divided by 2 will be -2. So I have x minus 2. And then here, 1 over 2 does not simplify, so x minus 1 over 2. I want the 2. I don't want any denominators, so I'm going to go ahead and move it up right here. So I'm going to have x minus 2 times 2x minus 1, like that. But don't forget, since this was x to the 4th, this is technically x squared. X squared, x squared, x squared. All right. Do we have any questions? Did I lose anyone? All right. So this is our factoring. Thank you for that question. Let me check. X squared came from where? Good question. So since this is x to the 4th power, when we break it up, it becomes x squared and x squared. Just like when we have like x squared plus 3x plus 10 or whatever, we break it into x and x. If this was 4th and squared, it would be squared and squared, so that we have x squared times x squared to make x to the 4th. Good question. Thank you, Walter. Awesome, cool. All right, so that is like what we were doing on Tuesday. That's the factoring portion. Now, since these are factors, we want, if you guys remember from quadratic, a solution is where it crosses the x-axis, right? So this and this would be our solution. In this case, we have something that looks like this. So we need to find our 4 solutions. 1, 2, 3, 4. In order to do that, what we need is we need to know where y equals 0, right? Where y equals 0, because that's that line right there, the y equals 0 line. So since that's our y equals 0 line, remember how f of x is just a fancy way of writing y, right? And so we really want to set these equal to 0. Right? We want to say like, okay, they're equal to 0. That's going to help me find where the line, where the quartic for like polynomial in this case is touching the x-axis. So what that lets me do is I'm going to go ahead and say, okay, x squared minus 2, that could be equal to 0, or 2x squared minus 1 is equal to 0. This is kind of the same as like, I think you probably just have like switched the signs in the past. But since we have x squared in this problem, we want to like actually solve it. We want to make it set it equal to 0. So I'm going to go ahead and add 2 on both sides. X squared equals 2. And then I'm going to go ahead and take the square root of both sides. That gives me x equals positive or negative since I took a square root. And then I'm going to leave it as square root of 2. So that's 2 of my answers. So I might say, okay, that's this answer and this answer here. And now I need to find the other 2. So I'm going to go ahead and add 1 on both sides. I get 2x squared equals 1. Divide by 2. I get x squared equals 1/2. And then I want to take the square root of both sides. So I get x equals positive or negative again, because I'm taking a square root of 1/2. I can rationalize this. I'm not going to worry about it for right now. This is my other 2 solutions, right? Those are decimal. It's just a decimal number. It's a square root of 1/2. So I should have 4 solutions since I started with x to the 4th power. So my 4 solutions are going to be positive square root of 2, negative square root of 2, positive square root of 1/2, and negative square root of 1/2. Those are my 4 solutions. So I should have 1, 2, 3, 4 solutions since it is x to the 4th power. What questions do we have? No questions for now? Okay. Feel free to keep asking them. All right. So this equation here, you don't need to draw this, but I'm going to show you. This is x to the 3rd. So it's going to look something like this. 1, 2, 3. It should have 3 solutions. 1, 2, and 3 solutions. All right, so look something like that. We're looking for 3 solutions in this problem. I want you to go ahead and practice your factoring from Tuesday. If it has 4 terms, which of these methods is going to be the best one for us? Which of these methods will be the best? Factoring by grouping, yeah, absolutely. So go ahead and take a moment, write down this problem here, and then go ahead and factor by grouping. Come back in 1 minute. We are factoring by grouping. So I'm going to split it in half. What can I divide out of 18 and 30? What can I take out of 18 and 30? The biggest possible thing. 6, yeah, 6. And I'm seeing 6x squared, which is great. 6x squared can come out of both of these. So I have 6x squared. And what's left over? Three x plus 5, perfect. 3x plus 5. 18 divided by 6 is 3. We have 3 x's on top, taking the 2 x's on bottom. So we're going to have 1 x left over, and then x squared's canceled here, and 30 divided by 6 is 5. Perfect. All right, what do 3x and 5 have in common? One, yeah, they just have 1. They only have one thing in common, which is 1. So we're just going to take out that 1. We have to take it out because we need the leftovers to be the same. So we need this to be the same as this. And the only way to do that is to take out like 1 from here. So we're factoring out a 1. In many cases, we wouldn't normally care about that, but since we want that 3x plus 5 to come out, we do care. So 3x plus 5. So we're taking, that's coming out here. And then left over, I have the 6x squared plus the 1. So 6x squared plus 1. All right, so we've done our factoring. What is the next step? Once it's factored, what should our next step be? This is that new step that we're going to do. That new step is that we want to know where it equals. We're going to set everything equal to 0. Thank you. We're going to set all the factors equal to 0 or set to 0. Love it. Thank you in the chat. So we would have 3x plus 5 equals 0. You can go ahead and solve that one on your own. And we have 6x squared plus 1 equals 0. You can solve that one as well. So subtracting 5 on both sides, I get 3x equals negative 5. Divide by 3 on both sides. X equals negative 5 thirds. So that is one of our answers. For the other one, I'm going to subtract 1. I get 6x squared equals negative 1. Dividing by 6, you get x squared equals negative 1/6. Take the square root. Remember, when we take a square root of a negative number, that's when we get that I situation. So I'm going to have positive or negative. It's going to be I, and I'm just going to do the square root of 1/6 like that. Whew, that's kind of funky, right? Those are imaginary numbers. So in this case, I don't actually care too much that you can get to the what are the imaginary numbers, just that you know that there are 2 imaginary solutions here, right? So there's 1 positive and 1 negative. All imaginary numbers come with a positive version and a negative version. They're conjugate pairs. They come together. They always come in sets of 2. So in this case, we would have 1 real solution and 2 imaginary solutions. So when we write our answers, we can write x equals negative 5 thirds and 2 imaginary solutions. If you want to write this section here, if you want to write the I version, if you're practicing your I and you want to do that, you can. But for the purposes of today's lesson, I'm not going to require you to do it that way, just so that you know that there are 2 imaginary solutions. All right. Cool. All right, on to the last one. This is our last one here. Go ahead and write down this problem here. All right. So I see that has 2 terms. I'm thinking GCF, I'm thinking cubes or squares. It must be one of those things. Does this have a GCF? Is there something I can take out? Yeah, the number 3, for sure, the number 3. So I have x to the 3rd plus 8, factoring out that 3 there. And now that it looks like this, I have x to the 3rd plus 8. It's more clear to me, oh yeah, those are cubes, right? So this is the sum of cubes. Because 2 to the 3rd is 8, for sure. So this is x to the 3rd plus 2 to the 3rd. That is the sum of cubes. So since it is the sum of cubes, I'm going to write down my formula. Remember, it's ombre, so it's going from A to B, going all A, some A's and B's to all B's, like that. And then SOAP, same, opposite, always positive. So the first sign is the same as my problem, so plus. The second sign is the opposite, so minus. And the last sign is always positive, so plus, like that. So when I plug these in, I have x and 2. So I'm going to do x plus 2. And then I would have x squared minus 2x plus 2 squared, which is 4. And don't forget to bring down that 3. Okay. So I have my factored form. So I have 3 equals 0. That's not true. So that's not going to work out. So anytime you just have like a number chilling by itself, we don't actually have to solve that one because it's not going to be equal to 0. But x plus 2 could be equal to 0, right? So minus 2, x equals -2. That is one of my solutions. And then I also have this situation, x squared minus 2x plus 4 equals 0. Since this is the sum of cubes or the difference of cubes, this part right here is always going to give you 2 imaginary solutions. So since I know this is the sum of cubes, I can just go ahead and write. I'm going to like literally memorize that this has 2 imaginary solutions. You can try to factor it. It's not going to work. You can try to use the quadratic formula. So you remember that long formula, x is equals -b plus or minus the square root of b squared minus 4ac all over 2a. There's like a little song. Did you guys learn the song? X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. Yeah, Eric remembers the song. Kayla remembers the song. Yes, it's my favorite song. It's not, but it's a helpful song for the situation. So if you were to do that, you would get down to it and you would have the square root of a negative number, right? So that like square root of b squared minus 4ac, that's going to be negative. And that means that you have 2 imaginary solutions. Is that only for the sum of cubes or for sum and difference? It is for sum and difference of cubes. So cubes are always, when you have the sum or the difference of cubes, this section right here, choose another color. This section right here is always going to give you 2 imaginary solutions for sum or difference, both of those. That was a great question in the chat. So sum and difference of cubes are always going to do that for you. So your answers for this question, x equals -2 and 2 imaginary solutions. If you want to go through the quadratic formula process and find those imaginary solutions, I'm not going to stop you, but I'm also not going to require you to do that. So you can just write 2 imaginary solutions for now. Okay. Right. What questions do we have about solving polynomials? None? All right. Keep asking them. I'm going to go over your homework here. So your homework, you're going to drop in a picture of your notes. You're going to check your answers from assignment 11. And then for part 3, this is going to have this website right here. It's going to have 44 problems on it. You're not doing all 44. You're just going to do 15 of them. You're going to find 3 of them that are difference of squares. You're going to find 2 of them that are sum and difference of cubes. You're going to find 2 of them that have an x to the 4th. You're going to find 4 of them that are just regular x squared, like trinomial. And then you're going to find 4 of them that are factored by grouping. I chose them with those numbers because that is how often they are to come up. So D and E are more likely to come up, and the difference of squares pretty common. Sum and difference of cubes and then x to the 4th are a little bit less common. So we're going to practice those a little fewer times. You can do as many as you want. There are 44. You can practice if you wish. So you're doing 15 total problems here. So you are not, I'm not asking you, let me see if I can open this. I'm not asking you, please hear me. I'm not asking you to do all 44, but there are 44 problems here. And you will also see the factored version in the answer key. So I don't think that you want to jump straight here because that would be probably not so good for your learning. But if you want to check that you factored it correctly, the factored version is here. But I am asking you to solve all the way, right? So your answer is going to be x equals a number. X equals a number, a number, a number, a number. So you are actually factoring and solving. Okay. 15 total problems. I don't want it to take you longer than an hour. If it takes you longer than an hour, please stop and just text me and say, Miss, it took me longer than an hour. I don't want you, just let me know and it'll be fine. Okay. Questions? Any questions? Okay, we have about 10 minutes. I'm gonna let you have some work time. I'll do some problems with you if you wish. So if you wanna work with me, you can stick around here. If you want to go to a breakout room, you can jump into them. It looks like Melissa, we have some people already like working together. So you can go ahead and jump into those breakout rooms. If you want me to put you in a breakout room because yours is not working, just let me know in a chat and I will drop you into a room. So just let me know. If you want me to do a problem, we can do it together. Cool. See some people popping into breakout rooms. Awesome. Okay, those of you who are still here, I assume you want to work with me? Is that a thing? Kayla, Eric, you guys working with me? Yeah. Sure, maybe. Okay. Okay, cool. So I'm gonna go to which of these methods do we want to practice? Which method feels like the most necessary to practice? Anybody can chat. Anybody? Nobody wants to work with me? Factoring by grouping. Great. Thanks, Brandon. All right. So I'm going to go to that website and find one that I can use factoring by grouping. So factoring by grouping is going to have 3 or 4 terms. So maybe number 5 might be a good one to do for factoring by grouping. So I'm going to go ahead and pull up that one here. All right, so I have 2x to the third minus 4x squared minus 3x minus 6. All right, so factoring by grouping, I'm going to split it in half like this. Number 5, factoring by grouping, I'm going to find something in common. What is in common between 2 and 4? Probably 2, right? 2 on both of them. And then I have 3 x's in one and I have 2 in the other. So there are 2 that are in common. So I could take out x squared. Yeah, 2x squared. Good job, guys. So I have 2x squared. And then left over is going to be 1x minus 2. Like that. Cool. All right. And then in this one here, I want to take out a 3. Take out a 3. I'm actually going to take out a negative 3 here because they have a negative 3 in common. So take out -3, and I would have x plus 2. That one's not going to work for me because I have x plus 2 here, but I have x plus 2 in one of them and x minus 2 in the other. I'm going to quickly see if there's potentially a typo on number 5. Let's go to number 5. Oh, number 5 says prime. So what that means is that, so since it says prime in my problem here, that means that I can't factor this one. There's nothing I can do. So the pink version up here, this pink version is actually the answer, right? There's nothing I can do. I can't do it. So I would have to solve this in a different way. For the sake of this problem, for the sake of like actually practicing, let's go ahead and change that -6 to a +6. If we change that -6 to a +6, we now have a minus here, because -3 times -2 would give us that +6, or 6 divided by -3 would give us. So I'm making a minor change to the problem so that we can keep working with it. All right, so we now have x minus 2 in both of them. So that's going to be my first one, x minus 2. And then my other one would be the 2x plus 2x squared and the -3. All right. So here I would have x minus 2 equals 0. 2x squared minus 3 equals 0. Adding 2 on both sides, I get x equals 2. And adding 3, 2x squared equals 2x3 equals 0. Dividing by 2, x squared equals 3/2. Square root both sides. We get x equals positive or negative square root of 3/2, like that. So I have 2 answers here and 1 answer here, which is good since I started with x to the 3rd. I should have 3 answers. Brandon, how do you feel about that one? Okay, good. So that's your major like factoring by grouping here. Is anyone working on a different problem that they would like to go over? Can do any number. Difference of squares, yeah. Let's do this one, number 1, since that is difference of squares. I see 2 terms and they're both squares. So number 1, this is difference of squares, and we have 9x squared minus 4. So I know that this is a square. It's 3x times 3x. 3 times 3 would be 9. X times x is x squared. And I know that 4 is a square, 2 and 2. So for the difference of squares, I know that I have 3x plus 2, 3x minus 2, like that. If I'm scared that I don't know that that's going to be true, I can always multiply it back together. 3x minus 2, 3x plus 2 gives me 9x squared, negative 6x, positive 6x, and negative 4. These cancel and leave me with just 9x squared minus 4, which is what I started with. So we're good. We factored it correctly, and then we're just going to set them equal to 0. So 3x plus 2 equals 0. 3x minus 2 equals 0. I'm going to subtract 2 on both sides. 3x equals negative 2. I'm going to add 2 on both sides. 3x equals positive 2. Divide by 3. I get x equals negative 2/3 and x equals positive 2/3. So I have two answers, which is good because I had x squared. How are you feeling about that one, Diana? Good, awesome. You're welcome, of course. How do we know which ones are difference of squares or factored by grouping? Yeah, good question. So if I'm looking at this, at these problems, I looked mostly at how many terms they have. So since this one has two terms, I know it's either difference of squares or difference of cubes. And since these are squares, I know it's difference of squares. If I'm looking at a problem like this, where it has three terms, I know that this is quadratic form because it has three terms. So it might be quadratic form with x to the fourth power, but it's not because it's x to the third. So I can see I'm going to take out an x here, an x here, an x here, and I'm going to take out 7. That's going to leave me with x squared. So this would be like from the D group, the quadratic form with x squared in it. Right? I'm looking at how many terms they have. So since this one has 4 terms, it has to be factoring by grouping because that's the only thing that I can do. Since this one has 2 terms, I see that it is squares, but it's a difference of squares, so it's actually not going to work. So it's just going to be GCF. The only thing I can do is take out a 3 from each of them because it's addition, so it's not the difference of squares. However, with this one, it is the difference of squares because I would take out the 50s from 50 from here and 50 from here. That's going to leave me with 4, which is a square, x squared, which is a square, and this will be 1 when I take out the 50. So 1 is a square as well. So you're referring back to your notes from Tuesday about like how many terms there is, like how many different numbers there are, tells me which format to use or like which method to use. That's a great question. Okay, it's 10:30. I'm gonna let you go if you need to go. If you want to stick around, I'm gonna do number 20. So if you want to stick around, I'm gonna do number 20. Otherwise, adios. Office hours are at 3:30. So I'll see you guys at 3:30. Bye guys. All right, let's do number 20. Here's 18. Here's 20. First thing is that decimal point is not actually there. Just ignore that decimal point. I don't know, that probably helps. So we have x to the fourth minus 4x squared plus 3. Bye, Golly. Have a great weekend. Okay, so I know that this is quadratic form because I have x to the fourth, x squared, and a number. So I'm going to solve it like with my x factor kind of thing. So what multiplies to get 3 and adds to get -4? What two numbers multiply to get 3, add to get -4? Three and 1, and not just 3 and 1, but -3 and -1 because we have to make -4. Yeah, negative for sure. All right, so I'm gonna have x squared since it's x to the fourth. So x squared and x squared, and then -3 and -1. Like that. Cool. All right, there's nothing I can do with x to x squared -3, but I can break this. This is now the difference of squares. Bye, Kayla. So I have x plus 1, x minus 1. Like that. All right. From there, I can do x squared -3 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So I'm setting them all the factors equal to 0 to solve. So I'm going to add 3 here. X squared equals 3, square root. X equals positive or negative, square root of 3. So there's 2 solutions coming out of there. I'm going to subtract 1, x equals -1, and then add 1, x equals +1. So my four solutions are the square root of 3, the negative square root of 3, -1, and +1. And that's good because I started with x to the 4th, so I should have 4 answers. 2 here, 1 here, 1 here. How do we feel about that, Mia? It was just a decimal. Yes, I apologize. Yes, no, that's just a typo. And I can't fix it because it's a PDF. Sorry. Yeah. All right, team. This is the end of our class. If you have another question, bye, Walter. You're welcome. If you have any more questions, I'm happy to stick around, but you probably have to go to Spanish. So enjoy Spanish class. And if you want me to go over another one, I'm happy to. Bye, guys. Have a great weekend. Adios. Bye, Diana.